Good morning, everybody. Thanks for coming. My name is Ben Thomas. I'm a senior research associate at the University of Bristol's Smart Internet Lab in the United Kingdom. I'm going to be chatting briefly this morning before our fireside talk with the rest of the partners in this project about the 5G tourism applications that we've been researching. A bit briefly about what's been going on at the University of Bristol and how we arrived at what we're doing. The United Kingdom, the UK Department for Culture, Media and Sport funded a 5G testbed in Bristol, elsewhere in the United Kingdom. And we've constructed a 5G testbed where we're open to collaboration to research what 5G could mean in different domains, in different industries, and different fields of interest. So in this case, we've been studying with our partners about tourism and what it means. So tourism in the west of England, around Bristol, is quite a large part of the economy. We're blessed in the area with some real prime heritage sites. Namely, in particular, we have the Roman Baths, which is some 2,000-year-old leisure centre, you could think of it as, but it's become a little bit more than that with the heritage situation there. It's worth billions to the local economy, and the real question that was put to us was, what's 5G going to do for tourism? What's 5G going to do for heritage? And we researched that, and we have some answers essentially. So working with CCS. The BBC and Zeta Networks in Bristol were able to take some of the applications that are promised from 5G, from 5G KPIs, low latency, enhanced mobile broadband, and Internet of Things, massive machine-to-machine communication, and applied them to the tourism sphere. Now, in this case, primarily we focused on the low latency side of things, and what that means is, who recently has been to a museum? Actually, might ask. So, there's a few people. So. Do you see there's the tour guide, the audio tour guides you can book, and they're a bit clunky, aren't they? It's a bit of a throwback to the 90s, and one must ask really why do we still use this kind of tech when, you know, we're right on the cusp of having sort of better immersive augmented reality, virtual reality applications that could run over 5G, and that's something that we worked with and that we developed. Essentially, it amounted to. Imagine yourself in the Roman Baths, looking at the heritage site. It's a bit, mind the step. There's a couple of cracks in the concrete. It's a bit of an old-looking, it's a bit of an old beast. But with an application on your handset, Aardman Animations were able to develop a 3D rendering of what the Roman Baths looked like previously. Once, when the Roman Baths were just a mere hot spring in the water, in a field in the area, to when the Romans actually constructed it, and then once the Romans left, as the building began to fall into decay. Now, so you move your handset around using onboard and offloaded out in the network functions. We're able to track the user through their perspective, and they're able to see almost like a window through time is the terminology. We're able to see what the Roman Baths looked like. This is a handset app, and it doesn't seem that exciting on the front of it. But what is exciting is we're able to use some 5G technologies like multi-access edge computing to get that low latency that's needed, so that the video rendering or the 3D space rendering doesn't take place in the handset, it takes place in the network. So it doesn't matter if you have a cheap phone, an expensive phone, an iPhone, a Samsung, Android, iOS. Everything's done remotely. Everyone gets the same level of service, and we make use of the compute functionalities that are broken up in the center of the 5G network and a bit more close to the edge to get that latency. So really, the whole project was about enhancing the user experience, moving away from these 1993 audio tour guide situation to something that's a bit more exciting, it's a bit more accessible to visitors of heritage sites like at Bristol. And it couldn't have been possible without the work from the University of Bristol, Zeta Networks, who drive their SDN controller. Aardman Animation, who were fantastic in rendering the 3D space, and of course CCS then, who provided the wireless network connectivity that was possible to make this happen. In terms of results, in terms of what we learned, there's a few key things. One, the 60 gigahertz mesh network that CCS provided us, it really does work. And you might not know, but Bath is quite a pain to install infrastructure in. It's a UNESCO World Heritage Site. You can't just go drilling dishes anywhere. But the ability of the CCS mesh network running at 60 gigahertz was able to rapidly deploy our network to where we did have permission, not to where would have been most convenient for line of sight. So that was a real good planning boom for us. The second main thing that we took away was that MEC does work and that we're able to lower the latency such that such an application is exciting and it is possible. So I think that's pretty much what I've got to say for an introduction. I'd like to introduce onto the stage the partners in this project who are from CCS and Zeta Networks, and we'll be taking questions on this fireside talk. Thank you very much.
Thank you. You can actually
Take a seat.
That one.
Oh, great.
Yeah, I'm going to grab another
Smashing,
one.
okay.
This one
The clicker, but I had no slides. So.
Turned on? Hi everybody, thanks Ben. Thanks for the introduction to the project. So, as Ben said, CCS, Cambridge Communication Systems, over the years we've developed a self-organizing mesh millimeter wave technology that essentially provides gigabit backhaul connectivity, so extending a fiber through a city environment to locations in the area where basically it's very difficult to get fiber. Or very expensive to deploy fibre as well. So as Ben gave the example in the Roman baths and around Bath, which is a very historic area, it's extremely difficult to deploy new fixed fibre services in those areas. We used our new 60 gigahertz millimetre wave mesh technology to extend the fibre and effectively provide a very high capacity, low latency connection into the baths that then connected in the cloud and the core network through to the access network. So that was our role in the project. And we also provided a 26 and 28 gigahertz mesh in the Bristol area for the Millennium Square project. And our role there was to provide, again, connectivity, and the application and use case there was public safety. So Justin will talk a bit about the public safety and the network slicing that was running over that system. Okay?
Yep.
Thanks.
Hi, so I'm Justin Paul from Zeta Networks, and we were one of the partners in the Catalyst. What we do, we're a software company, a startup in Bristol, is we do a lot of work around software-defined networking, how you build, manage, and slice networks, particularly in the 5G space. As we know, tourism is very important to economies, but it's also very important that you as a city, you as a venue are able to protect and keep your tourists safe. So one of the aspects we really focused on was how you would manage public safety networks alongside major tourist attractions. And I think we all know when you get a lot of people together in one place today, the networks tend to suck a little bit. And that creates all sorts of problems if there's an incident, if there's a requirement to do something different. So we looked at how you can slice the network. And that's what we did in this case. We sliced the network. We created a tourism slice, a sort of general public slice, but also that could be something that could be offered as part of the venue's experience, so that people don't build up big data fees. But we wanted to be able to deliver a public safety capability. And most of the time, public safety users don't require a lot of bandwidth, but sometimes they do things that do. And we did some work around thermal imaging cameras. There are all sorts of image processing apps around people leaving baggage, identifying people in a crowd that are quite bandwidth intensive. And what we showed was the ability to flip up a public safety slice that took priority over everything else, run that slice, and then tear it down at the end of the event. So you could guarantee and protect the public safety capabilities in and around all the work that was going on around the smart tourism, that very dense, high bandwidth requirement. And that's really what we've been doing, and it's been a lot of fun. Thank you.
Okay, so thank you. My mic working? Yeah, it is? Okay. Sorry. So we had a really good, okay, now it's definitely working, overview of the project. Thank you, gentlemen. Can you tell us a little bit more about why you needed 5G specifically to deliver this application?
Yeah, I mean, I think it's a really good question, because when you look at a lot of the trials, because they're not done at scale, people say, well, couldn't I do this with Wi-Fi? Couldn't I do this with 4G? And there are one or two things that you can only really do with a proper 5G network. The first is virtual reality, augmented reality. If any of you had a go at some of those games, if they're slightly out of sync, if they're delayed, you get quite nauseous. It's quite an unpleasant experience. You need very, very low latency in the networks to overcome that. So that's the first thing that 5G delivers. We talked about mobile edge computing. The ability to process things off the phone is hugely important. Anyone who's been out and about for a day will realise your battery life gets hammered. And if you're using mobile edge computing to do all that heavy lifting on the device, it actually preserves your battery life, which is actually really important to the tourist experience. And I think the final thing is that ability to deal with very dense networks, lots and lots of people at an event or a cultural event, all using their phones, all activating social media, hammers the network in a way that only 5G networks can really support.
I think you hit the nail on the head there. I mean, the low latency, high capacity required for the applications that we talked about is key. And part of that is the access network, which connects in the handsets. Part of it is the transport network, the backhaul network as well. Obviously, the ultimate goal would be to bring fibre to every site, but you can't do that. So you need other technologies like millimetre wave transport solutions. Clearly, they have to be much higher capacity than microwave transport solutions have been in the past, and maintain low latency as well. So delivering, for example, a sub 1 millisecond latency end-to-end over a transport network is a requirement. Being able to deliver 1 gigabit, 10 gigabits over these millimetre wave networks is also a requirement as well. So you need both the capacity and the latency.
So my next question is actually going to be about the millimetre waves in what you talked about, Justin, the public safety network. So can you tell us a little bit more about that? We heard about, obviously, the latency, but tell us a little bit more about the specific role of the millimetre waves in public safety networks, please.
Okay, yeah. Well, the higher frequency that we run in our mesh gives us access to much more spectrum than you would have at lower frequency. Lower frequency unlicensed technology is been used very widely for Wi-Fi applications. The noise floor has been rising over the years. Probably in an area like this, you get pretty patchy Wi-Fi, and it would be quite, the performance won't be good enough to be able to stream content or run low latency applications. So I think getting to millimetre wave gives you access to, much more spectrum. And it allows you to run much lower latency services as well. So you can guarantee quality of service basically over that network end to end, which is something you probably couldn't do before in the lower frequencies.
I mean, I think to that, one of the things we did in the public safety piece was a deployable instant area network. Effectively, we had a van with a thermal imaging camera and a CCS millimetre wave node, and you were actually able to drive that to site, deploy it within minutes, effectively run the node up a pole, and then you'd be streaming live thermal imaging imagery, roughly about 40 megabits per second, so not huge, but not insignificant, back to the control room to help support emergency services. And it really was a very resilient and useful technology for that public safety demonstration.
So BBC R&D, who are one of your champions on this project, decided to go for a private cloud to host their augmented reality app. So can you tell us a little bit more about why they chose a private cloud as opposed to a public cloud?
Okay, so this question really addresses the move that the industry is going to be taking where you raise the question, well, lots of apps at the moment, they make use of the public cloud. They're quite happy on AWS, on EC2 instances, that sort of thing. So why would they make use of a private cloud that an operator might make available? Well, in this case, there's two main things that were really pressing on this. One is the nature of the app is an augmented reality app. It requires very, very low latency. You have to take a feedback loop from the handset, send it out to the compute resource that's apart from the handset, and the data gets fed backwards to the device. So that the latency of the application is very low. In our tests, we were getting 2, 3, 4 milliseconds of latency, which was delivering a lovely user experience. And that can't be delivered from a public cloud like AWS or Google Cloud Compute. The compute resource in that case, it could be in Amsterdam, it could be in North America. It's a very far away, and the only way they're going to really address that problem is to bring the compute closer to the user. And in this case, the best person to do that would be the operator, who, wherever their eNode Bs or their G-Node Bs in the 5G world are going to be, that's where the compute can be, that's where the latency can be cut down. The other main reason that they were quite keen to use a private hosting solution was based on the hardware requirements of the application. So for those of you who are familiar with booking things on public cloud, you can book your CPU, your RAM, storage capability, and that sort of thing. What you can't really do is drill down to specifically the kind of hardware you want. So if you want, say, for example, GPU compute resource, which one you get is going to be down to whatever the market really wants the most of. Do you want it for AI processing, or do you want it for rendering graphical images? And it's a difference that being the user, when you do it yourself, you do it right. But if you rely on the public cloud, you're going to struggle to get precisely what you want to precisely eke out the performance that you want from the application. So yeah, private cloud in this case was something that really worked for the project.
Is this working? No, okay, it's working now. Sorry. Speaking about this application, how else do you think the similar business model might be used? What's the scope of the opportunity for future applications?
Well, the business capability, the business sort of reach of this is quite interesting. And if you look at the revenue of network operators today, we've saturated it. As many people there are subscribers, and the amount the subscribers are paying is actually going down. So from a business point of view, such an application as this, where your museum it has an application that requires hosting local to the user, there's a perfect business opportunity for the network operators to get in and to create their own cloud infrastructure, where the museum or the application developer will be able to host their resource there and create a new revenue stream for the network operator, diversifying their business model a little bit, moving away from subscribers, moving more towards hosting for specific applications.
If I could be a little bit more radical around that, I mean, I think one of the things we've seen, there hasn't been a lot of innovation in the business models in the industry. Effectively, you've got business to consumer, and you've got an adaptation of business to consumer, which is done as business to business, which with the discounts and everything else. And the industry does need to innovate much more in terms of the business models going forward. One thing I think you'll see with 5G is there aren't many things you can do with 5G in the consumer space. You know, how fast you want to watch Netflix. It's about industrial and business-to-business applications, and that requires new business models. And I mentioned before, who pays for that application? When you go to a museum and you watch something, potentially you're transmitting a lot of data, but in most cases it's not going very far. It might not even be leaving 100-meter perimeter of where you are. You need a business model that reflects that, and perhaps the exhibition, the venue itself will be paying for that, the transport of that data in what you call the sort of Amazon Kindle model. You know, if you take the app to look at the artificial reality, the cost of buying that covers the cost of the data, etc. And I think we need to see much more innovation in and around the industry around that if the technology is to be a big success.
So, a two-part question, really. Are you planning on pursuing this project any further? And if you haven't really thought about that, what might you possibly be able to explore further along the same lines?
So, from the university's perspective, we're very keen to continue researching this, and in particular, the area that we're really focused on at the moment is, I've talked about placing the compute function of an application closer to the user, bringing it into the Mac, bring it into the 5G network. But we can go a step further than that, and we're really keen to analyze the network, analyze where the traffic is flowing, analyze and understand where compute resources might be free, and then using machine learning and AI to support application developers and application users in hosting their application in the best place in the network. So it's not always intuitively, it's not always true what might be intuitive. You think that it would be straightforward just to put an application directly where the user is, but it might not necessarily be so. There are some things that might be hidden in the details that an AI or machine learning could pick up and break the application up into 2 or 3 parts and host them in other places where it might be cheaper, where the balance might be right between cost and performance, and all the other metrics that go with it. So we're really keen to take this forward and to study where really get a grip and measure the network, where resources are available, and then see how that would affect the application's placement in the network, where in the edge you actually want to place your virtual network function.
I think for CCS, we're pretty agnostic about the type of application that runs over the infrastructure and the backhaul network. We had to obviously provide table stake sort of KPIs, the latency, the QoS, the capacity requirements for the backhaul for the access network. But clearly, smart city infrastructure is due to grow and site densification is required. So you look at a mobile operator today, has 50,000 sites, they may need to densify by 10x to provide 5G connectivity. And that clearly requires many, many more sites in cities and rural areas as well. So it's about how do you get a connection to those whether they be small cells or macro sites, Wi-Fi access points. Neutral host is a big theme at the moment, so being able to reduce the TCO of that network by sharing it by multiple operators or multiple applications. So a local council may run a network as a service, but also may backhaul their public Wi-Fi network over it, or may backhaul their CCTV security cameras over it as well. And that obviously has a big impact in the TCO of a 5G network.
And I think from the Zeta's point of view, the good news is we were involved in one of the UK government's DCMS 5G trials, the Smart Tourism trial. That's now been extended. And the focus of the extension really is about scalability. So a year ago, there weren't many 5G phones around, and that was a problem to load the networks and do a lot there. That's improving, and we're hoping during the course of the summer to be involved in a number of events where we will start to stress test the networks a little bit more, see whether slicing works in a very congested network as expected, and really prove the technology, take it forward to the next step.
Great, thank you very much. We are out of time, but if anybody wants to hear more, see a demo, your booth is downstairs, right? Level 2?
Level 2.
So level 2 in the Catalyst area, which is within the expo area. Go and find these guys and get yourselves a demo. Thank you very much to our panelists.
Thank you.